Hello students! In our previous video, we saw what concave lenses and convex lenses are. We also saw that they bend light to form image of the object. Just as we know that lenses also form image of object by refracting light. And to make things easier and study them well, we take help of ray diagrams. We have already discussed some rules for making ray diagrams in the case of curved mirrors. There are similar rules for making ray diagrams with lenses also, and we need to know them. As we know, a concave lens is also called a converging lens as it focuses all the incident rays onto a single point, while a concave lens is also called a diverging lens as it spreads all the incident rays in different directions. Thus, due to the shape of both the lenses and their ability to refract light rays differently, the images formed by them are also having different characteristics, like size of the image, its shape, and its type. That is, whether the image is real or virtual are different. Conventionally, we use rays to know how these different images are formed. So let's first learn about the rules of making a ray diagram. But before we know the rules, let me tell you one fact. We know that when light passes through the lens, refraction occurs 2 times. Yes, at 2 surfaces. One, at the air and the lens interface while it is entering, and second, at the lens and the air interface while it is leaving the lens. But as you know, we consider only lenses with small apertures and small focal lengths. The thickness is not that significant here. And so we can consider one refraction that is happening at the center like this, instead of 2 refractions. Technically, what we are doing is neglecting the refractions happening in this portion. We consider that this portion of the light inside the lens is a part of an incident ray, while the remaining one is part of an emergent ray. Remember, this is just a consideration to make things simple and study easy. It is not actually happening like this inside the lens. Okay, so going back to the rules, let us see the first one in the list. Rule 1. It states that a ray of light from the object parallel to the principal axis after refraction from a convex lens passes through the principal focus on the other side of the lens. This parallel ray is also called as para-axial ray. Para for parallel and axial for parallel to the principal axis. In the case of concave lens, the ray appears to diverge from the principal focus located on the same side of the lens. So confused? Well, this will be clear if we make many parallel rays. Observe that they diverge from the lens on the other side. And we then extend these rays back. What we see is they meet at a focus point, or in fact they appear to meet at a focus point, which is on the same side as the incident ray. So what just appears to us is that rays diverge from this focus point instead of meeting at this point. Yes, so in actually they are diverging from the lens itself like this, but to an observer it seems to be diverging from this point. Now what happens inside this lens? I already told you to imagine the lens as an arrangement of small prisms and a glass slab like this. So now when rays fall on the prism, they bend like this in such a way that it passes from the focus on the other side of the convex lens. Similarly, we know that a concave lens is also an arrangement of prisms and slab. That is, they are inverted. So here, when light is incident, it will bend like this on outer side. And so we see that it is diverging from the lens. And yes, In both the cases, in convex lens and concave lens, the ray which is entering perpendicular to the pole, that is, which is passing through the glass slab like this, comes out unrefracted or undeviated on the other side. This is because we know that when light is incident at 90 degrees to the glass slab, it does not bend or refract. Yes, one more thing. In both the cases, as I told you, as the light passes through the lens, it refracts twice, as you can see here. One when it passes through air to the center of the lens, and then again when it passes through the lens into the air. But yes, we consider here only one refraction for the simplicity, happening at this optical axis of the lens, due to which the direction of the light rays change after refraction. For the convex lens, observe that the refracted ray that is emerging out of the lens actually passes through f2 on the other side, while for the concave lens, it appears to pass through focus point f1. Yes, it appears to pass because we have extended it back. And yes, on the same side of the incident ray. So we can say that what rule 1 says, that if ray is parallel to the principal axis, after refraction, it bends in such a way that it passes through the principal focus of the lens. Now what about other two rules? Well, we will see them in the next video.